My dear students, greetings to all. Myself, Abhilash Sajeev K. I'm working here at Al College of Engineering as an assistant professor in the mechanical department. Let's now discuss about the most important derivation at the first module of heat and mass transfer. Semester 6 heat and mass transfer, first module, the most important derivation, general heat conduction equation in Cartesian coordinates, derivation of general heat conduction equation in Cartesian coordinates. Let's begin. Let's consider a small volume element in Cartesian coordinates having sides dx, dy and dz as shown in the figure. Here G is the heat generated per unit volume. Let's now consider this element. Its sides are given dx, dy and dz, and G is the heat generated per unit volume. We can see that. Here, the energy balance of this little element is obtained from the first law of thermodynamics. What is the first law of thermodynamics? Delta U is equal to Q minus W. That is, change in internal energy is equal to heat minus work. Heat means heat input. Work means work done by the system to the surroundings. That is, delta U is equal to Q minus W. By using the first law of thermodynamics, we can elaborate it at the net heat conducted into the element dx, dy, dz per unit time and the internal heat generated per unit time. These both terms are Q minus W is equal to delta U. That is this term. These both terms, net heat conducted into the element dx, dy, dz per unit time and the internal heat generated per unit time. The addition of both these terms are Q minus work done by the element per unit time, that is W, is equal to increase in internal energy per unit time, that is delta U. Now you see this term is the first law of thermodynamics. Okay. Here the flow work done by the element is very small, so the term is neglected. So the work done by the element per unit time, that is, this work is the flow work, which is very small, so we neglect the term. Now the equation becomes Q net plus Q generated is equal to dou E by dou T. Okay. Q net is net heat conducted into the element dx, dy, dz per unit time. Q generator is internal heat generated per unit time. That is equal to dou E by dou T. That is increase in internal energy per unit time. Now we have to first find out what is the expression for Q net, then we have to find out what is the expression for Q generated, and then we have to find out the expression for change in internal energy, that is dou E by dou T, and then we substitute all those expressions into this equation. That is the way to go. Now first we have to find out what is the net heat. To find the net heat, we have to calculate how much heat that comes into the element minus how much heat that goes out of the element. To find out how much heat into the element, we have to look in the x direction. We have a heat Qx coming into the element. In y direction, we have a heat Qy coming into the element. And the z direction, we have Qz come into the element. So the net heat that came into the element is Qx plus Qy plus Qz. That is, here it is written as okay, heat conduction rate into the element is equal to Qx plus Qy plus Qz. Now what is the heat conduction rate out of the element? Let's look at the figure. The heat conduction rate out of the element in x direction, the heat conduction rate out of the element is Qx plus dx. The terms, we have to look at the terms, because for x direction, Qx plus dx is the heat that goes out of the element. In y direction, Qy plus dy is the heat that goes out of the element in y direction. In z direction, Qz plus dz is the heat that goes out of the element in z direction. We named it as Qx plus dx means because this heat travels through an x distance from this y-axis to the first surface of the element, that is x distance, and then traveled another dx distance. So that's why this heat is called as Qx plus dx. Now Qx is called in the name because when Qx passes through this first surface, that is surface perpendicular to the heat flow, it has just crossed only x distance, so it is denoted as Qx. Whereas this heat which comes out of the surface passed through x distance and dx distance, so it is termed as Qx plus dx. That's why. So here if we have found out that the heat conduction rate into the element is Qx plus Qy plus Qz, and heat conduction rate out of the element is Qx plus dx, Qy plus dy, and Qz plus dz. Okay, heat conduction rate out of the element is Qx plus dx plus Qy plus dy and Qz plus dz. Now, what is the net heat? Net heat is heat conduction rate into the element minus heat conduction rate out of the element, that is Qx plus Qy plus Qz minus Qx plus dx plus Qy plus dy plus Qz plus dz. Now we have just find out the expression for net heat transfer, Q net. Now we have to find out the expression for Q generated. So what is Q generated? Q generated is equal to G into volume, because what is G? G is, we have assumed that G is the heat generated per unit volume. Heat generated per unit volume, that is G. So to find out internal heat generated for the entire system, so we to find out the internal heat generated, we have to multiply with the volume, so that we could find out the internal heat generated for the entire volume. So Q generated is equal to G into volume. Volume is dx, dy and dz, as we know. So we just find out the expression for Q generated, that is G into dx into dy into dz. Now we are trying to find out what is the expression for dou E by dou T. So here we all know that Q is equal to mc delta T. We all know that Q is equal to mc delta T. Q is equal to mc, that is delta T is a change in temperature. Here we have written as dt, that is also the change in temperature. So if Q is equal to mc dot dt, then dou Q by dou T is equal to mc dou T by dou T. That is, change in heat per unit time is equal to mc dou T by dou T. Mass into C into change in temperature per unit time. We all know that dou Q by dou T is equal to dou E by dou T, because change in internal energy is equal to change in work, change in heat. Change in internal energy is equal to change in heat. That's because we have just neglected the work term in this equation. So here the increase in internal energy is equal to all heat. So change in internal energy is equal to change in heat. Actually, change in internal energy is equal to change in heat minus work, but we have neglected the work term. So here the change in internal energy is equal to change in heat. So that's why we have written as dou Q by dou T is equal to dou E by dou T. So in this way we have termed as dou E by dou T is equal to dou Q by dou T is equal to mc dou T by dou T. for here mass is equal to density into volume. So dou E by dou T is equal to density rho into volume dx dy dz into C dt, dou T by dou T. Now we have finally found out what is the expression for change in internal energy. Now we have to substitute these three terms, that is change in internal energy, Q generated heat, and Q net to this equation. So that's what we are doing. Okay, substituting equation number 2, 3 and 4 in the first equation. So all this term is net heat, this term is generated heat, and this term is change in energy, that is qx plus qy plus qz minus qx plus dx plus qy plus dy plus qz plus dz plus g into dx dy dz is equal to rho dx dy dz into c into dou t by dou t. Using Taylor series, we know that qx plus dx is equal to qx plus dou by dou x of qx dx. Qy plus dy is equal to qy plus dou by dou y of qy dy. Qz plus dz is equal to qz plus dou by dou z of qz dz. Now these all are the Taylor series expansion. We are substituting here we have substituting all these Taylor series expansion into this equation in the place of qx plus dx and qy plus dy and qz plus dz. While upon substituting, all these qx, qy and qz terms will be struck out as they subtract each other. qx and minus qx, qy and minus qy, qz and minus qz. Now this is the remaining term. In this we know that from the Fourier law, that is qx by x is equal to minus kx dou t by dou x. This small qx is the heat flux. So for heat flux is equal to minus kx dou t by dou x. Now qx plus by x is equal to minus kx dou t by dou x. Qx is equal to minus kx ax into dou t by dou x. Similarly, we all know that qy is equal to minus ky ay dou t by dou y. Qz is equal to minus kz az dou t by dou z. These terms that we have studied, these terms, how it emerges in the derivation of Fourier law. Okay, from the Fourier law we obtain these terms. Now we have to substitute all these three terms, these three equations, to equation number 5. It's the previous equation. So minus dou by dou x of minus kx ax dou t by dou x dx minus dou by dou y of minus ky ay dou t by dou y dy minus dou by dou z of minus kz az dou t by dou z dz plus g into dx dy dz is equal to rho dx dy dz c dou t by dou t. Now we just rearrange these equations and we took out dx, dy and dz out of the equation. Now on every term there is a part of that term, that is dx, dy and dz. We by dividing all the terms with dx, dy, dz, we just cancelled all the dx, dy and dz terms. Now the remaining term will be dou by dou x of kx dou t by dou x plus dou by dou y of ky dou t by dou y plus dou by dou z of kz dou t by dou z plus g is equal to rho c dou t by dou t. Here we assume that the thermal energy is same for every direction. That is, the material is isotropic. Kx is equal to ky is equal to kz is equal to k. That is isotropic property. Okay. So if kx is equal to ky is equal to kz, then we can take out all these k terms from there. So we took out k from all the three terms. So k into dou square t by dou x square plus dou square t by dou y square plus dou square t by dou z square plus g is equal to rho c dou t by dou t. Now we divide by k. We divide k to all the both sides of the equation. So here the k in the numerator and k in the denominator strikes out. So the equation becomes dou square t plus by dou x square plus dou square t by dou y square plus dou square t by dou z square plus g by k is equal to rho c by k dou t by dou t. We know that k by rho c is equal to alpha. What is alpha? Alpha is thermal diffusivity. So the final equation becomes dou square t by dou x square plus dou square t by dou y square plus dou square t by dou z square plus g by k is equal to 1 by alpha dou t by dou t. It is the unsteady state heat conduction equation with heat generation. Here the g term is there. So it is this equation consists of heat generation component. And it all this equation also contains dou t by dou t, so it is an unsteady state. For steady state equation, dou t by dou t is equal to 0. Then the equation becomes dou square t by dou square plus dou square t by dou y square plus dou square t by dou z square plus g by k is equal to 0. Now this is an steady state heat conduction equation with the heat generation. Now for steady state heat conduction equation without heat generation, we have to assume that g is equal to 0. So the equation becomes dou square t by dou square plus dou square t by dou y square plus dou square t by dou z square is equal to 0. Do you guys familiar with this equation? This is the Laplace equation, that is del square t is equal to 0. So this is the heat conduction equation in Cartesian coordinates. Okay, thank you for listening to me.